Yes, now screen visible.
Yes, sir, visible.
So this is the question. So first of all, I just tell you that how we define the negative feedback. Okay, just apply the voltage. Okay, and check we are getting the positive voltage or negative voltage. So here we create two loops. In this question, if you see that we have a two loops. One is upper side and one is the bottom side. Okay.
Yes, sir.
Now we break the loop, increase the voltage. Okay. So if we increase the voltage, what we are getting, like for example, we increase the 1 volt here. Okay, we increase the 1 volt here. So what is the voltage at this point? This 1 volt go into the feedback. Okay, there the
Yes,
particularly 10 kilo ohm and 10 kilo ohm two resistance are given. So basically the voltage will be divided in two parts and it will be grounded. So 0.5 volt will be drop across this point and 0.5 volt will be drop here. So that means this terminal we are getting is 0.5 volt. Clear?
yes, sir. Yes, yes.
Now if we see the upper side, so 1 volt and 5 volt, that means 6 volt all will be appear here. So the voltage will be 6 volt and this 6 volt will be drop across this 10 kilo ohm resistance. So that means this point voltage is 6 volt. Okay. So one point we are getting a 6 volt, one point we are getting a 0.5 volt. Okay. Now if this is a positive terminal and this is a negative terminal, that means output voltage is 6 minus 0.5, that is a 5.5 volt. So we are getting a positive voltage here.
Yes, sir.
Okay.
Okay.
And if
Okay.
we consider this one as a negative and this one as a positive, so minus 6 plus 0.5, that means we are getting a minus 5.5 volt. We are not talking about the magnitude, but the voltage will be in the downward direction.
Yes, sir.
Okay.
In this way,
So where we are getting the higher voltage, we consider for the negative feedback, we consider that terminal is an inverting terminal.
yes, sir.
Okay.
Now I
So
understood.
that's why this terminal will be negative, this terminal is positive.
We have to calculate in this way all time, no, sir?
Yeah, we always calculate this way.
Okay.
Okay, which terminal having the higher voltage, we consider that is a negative voltage for the
Ne-
negative feedback.
for negative feedback. Yes, sir. Okay.
Okay, now along with that we calculate the output voltage also. So we know that this point voltage will be what, and this point voltage is what. The question number 10, this is the question number 10. In the question number 10, we have to calculate which terminal is negative, which is the positive terminal. So 5 volt is connected to the inverting terminal. This is the question number 10. Now question number 11, I think we have to calculate the output voltage also.
Yes, sir.
So how we calculate the output voltage?
Sir, VAVB are equal. Then,
So
uh,
I consider that this is the VA, this is the VB. Simply.
yes, sir.
Okay. So what is VA? VA is 5 volt plus V out.
Yes, sir.
Okay, and what is VB?
So 10 by 10 plus 10 into V0.
V out into 10 by 20. Apply the voltage divider biasing. This V naught. This V naught will be divided into two parts. So here is the V naught by 2 and here is the V naught by 2. That means V naught into 10 by 20. That is V naught by 2. So this is equation number 1, this is equation number 2. Now if we create equation number 1 and equation number 2, so 5 plus V out is equal to V out by 2. Okay, so 5 is equal to minus V out by 2. That means V out is minus 10 volts. That is the question number 11. Okay, any doubt? Any other doubt? I think in the question number 7, some student having the doubt. They ask in the G space yesterday. So doubt is clear or should I solve it?
Clear, sir.
Okay. So I think no doubt in the week 1 and week 2. Is it? Or if you have any doubt, you can ask. Otherwise, we will start the week 3.
Sir, in question 9,
Yeah.
graded assignment 2, I did it direct formula.
Mhm.
Uh, for three resistance, that is
Okay.
direct V out,
Okay.
V output voltage V0 equal to, for two
Mhm.
resistance, that is V0 equal to plus
Your voice is
R2,
breaking.
V2 into R1 by R1 plus R2.
Yeah. So basically, we know that if two particularly resistance are there, so we are calculating V1 into R2 by R1 plus R2 plus V2 into R1 upon R1 plus R2 times 1 plus RF by R in minus V in the negative terminal multiply with RF by RA. That is for two resistance. I think we solved in the last class.
Yes, sir.
Yeah.
And if there is three resistance,
Then the formula will be different. We can't use the same formula.
yes, sir. Can you write that formula?
Uh, Formula,
Is
okay. So first of all, how we solve that one? After that, we will calculate the formula. So I'm just copy that one. Okay. This is my question. So negative inverting terminal voltage is same.
yeah.
Output voltage V out is V minus V negative into RF by RA. That is same. Okay. Only the positive terminal voltage will be different. If I consider this is the V1, this is the V2, this is the V3. Okay. So V1 now, if V1 I consider, so V2 and V3 both are will be grounded. Okay, both will be grounded.
Yes, sir.
So when we consider this is the V1, so the voltage drop across this particularly two combination. So R2 parallel with R3 divided by R1 plus R2 parallel with R3. Okay. Plus,
Yes,
if we
sir.
consider this is the V2 voltage, so V2 when we consider, so this R1 and R3 will be in parallel. So R1 parallel with R3 divided by R2 plus R1 parallel with R3 plus, if we consider the V3, so R1 and R2 is parallel. So V3 R1 parallel with R2 divided by R3 plus R1 parallel with R2. Okay, and whole multiply with gain 1 plus RF by RF.
Yes, sir.
Okay,
Yes, sir.
so if we put the value, so V out is minus, okay, here it is not connected anything, negative, so this is 0. Okay, so this point is 0. 1 plus RF by Rn is what? So 1 plus
Sir,
20
5.
by 5, 20 by 5, that is a 4. Okay, now V1 is 2 volts. So 2 into 4 and 8 parallel combination. Okay, so 4 and 8 parallel combination is 32 by 12 divided by 2 plus 32 divided by 12. Okay, sorry. Plus 1 into 16 by 10 upon 4 plus 16 by 10 plus 1 into 8 by 6 plus 8 plus 8 by 6. So outer is a 5. So it is a 64 by
By
56 plus
56. Yes, sir. 16 by 56.
16 by 56 plus
8 by 56.
8 by 56. So 5 into 88 by 56.
That is 7.85 volt.
Yes, 7.85 round. Hmm. Yes, Prince. Prince, any doubt?
Yes, sir.
Yeah.
In the starting,
Hmm.
you said ground the 1 volt and 1 volt, right? In this question.
Yes. Yes.
Then
We
what?
apply the superposition theorem. Okay.
Oh, okay.
We apply the
And one.
superposition theorem. Consider one voltage source and two will be the grounded because it is a voltage source. Voltage source will be replaced by the short circuit.
Oh, okay, got it.
Okay.
And
So
one
one.
more approach she can used.
Yeah,
Uh,
you can apply the particularly current voltage at this point VA also
no,
by
no.
node.
She want to use R1 R out by R in. Then she can find the equivalent resistance and equivalent voltage. Then she can.
Yeah, you
Is
can
it?
apply the VTH voltage Thevenin theorem apply. You can apply the Thevenin theorem. So calculate the VTH and RTH also. Okay, you can apply basically uh, some other approach also you can apply in that one. Mm, so you consider that all three because all three are the voltage source. So the current will be coming in this one, current will be coming in this one, current will be coming in this one. All three current will be here. So
Yeah,
what is
nodal
the voltage drop you
analysis.
can calculate? Yeah. So the approach you can use any approach you can use. Generally, we are using the KCL. KCL is the easy. Okay, you are familiar with the KCL more better as compared to the if we apply the superposition theorem or Norton or Thevenin theorem. So KCL is easy, so that's why we generally use the superposition and KCL. Okay, otherwise you can calculate. The method is same. You have to find out this voltage. Okay, this point voltage is if VA, so you find out the voltage VA, and now after find out the VA voltage, you just multiply with the gain. So V out is nothing but VA times 1 plus RF by RA.
Yes, sir.
Okay, now VA you can find out in any way. Either the superposition theorem you can apply, either the Norton analysis you can apply. Okay,
Yes, sir.
Prince.
Yes, sir.
Any other doubt? Week 1 and week 2 graded assignment.
So
Yeah.
I have doubt in question number 13, week 2.
Question number 13, week 2. Hmm, okay. Yes. So output voltage. I just copy. I think this is question number 13.
Yes, sir.
Okay. So first of all, we consider that this voltage is V naught 1. Okay. So V naught 1 is, we apply the positive voltage. Okay. Sorry. We apply 2 volts at the non-inverting and 2 at the inverting terminals. Okay, so if we apply the superposition, so 2 volts is here, that means 2 volt is also here. Okay, if 2 volts and 2 volts are here, so that means at this point we are also getting the 2 volts.
Yes, sir.
Now can you apply the KCL?
Yes.
This is the grounded, this one is the grounded. I just consider this is the grounded part because we apply the superposition theorem, so this is the grounded. Now the current, all outgoing current, I am considering the all are the outgoing current, so all outgoing currents will be equal to 0. So if I say this is the I1, this is the I2, this is the I3, all will be, addition of all three will be 0. So I1 plus I2 plus I3 is equal to 0. What is I1? 2 minus 0 because it is a grounded, divided by 2 plus 2 divided by 4k plus 2 minus V naught 1 divided by 4k is equal to 0. So k you can take a common and just you multiply here, so k will be cancel out. Okay, so 2 divided by 2 is 1 plus 2 divided by 4 is 0.5 plus 2 divided by 4 is 0.5 minus 4, sorry, V 01 by 4 is equal to 0. Can I take it this side? Okay, so V naught 1 is the 8 volt. Okay, this is because of this 2 volts.
Okay, sir.
Okay, now we consider the second volt source as a 0. So this one will be 0. This will be the grounded. So I just consider the V0 positive, and because of V0 negative, uh, this point is the grounded 0 because this is a grounded, so this point is 0. So now again we apply the KCL, so current will be going in this direction. At this point the current will be distributed here and here. So I just consider this is the I1 dash, I2 dash and I3 dash. So I1 dash is equal to I2 dash plus I3 dash. Current that is coming to this node, it will be going into I2, and this will be going in I3. So what is I1 dash? 2 minus 0 divided by 2 is equal to, what is I2? I2 is 2 divided by, sorry, that is 0 divided by 4 plus I3 0 minus V01 negative. So V01 negative divided by 4k. Okay, so 1 is equal to minus V01 divided by 4k. Okay, that is also 2k. So k and k cancel out. So V01 is minus 4 volts. Now total V01 is what? Total V01 is V01 plus
4 volt.
plus V01 minus. So that is 4 volt. Okay. So
Yes, sir.
this point we are getting the 4 volts. Now this 4 volt apply to this particularly. So 1 volt that is connected on negative terminal. So V naught is 1 multiply with RF by R1 with minus sign. Okay, if
Sir,
we
we have
consider,
to
yeah,
sir, we have to find V01 and V02 separately.
V02 is where?
No, V01 you have find V01 that is 8 volt. Then
Yeah,
again
yeah. V1
V02
first
plus
I consider the positive terminal voltage. So
yeah.
I am getting the V01 positive. Second, we consider the negative voltage. So I consider the V0 negative.
Okay.
Okay. You can apply with the same method. You can apply with the same. No need to calculate the superposition theorem. You directly apply the KCL also.
Yes, if I apply directly KCL, then I got 4 volt directly, no?
Yeah, forward you can get
After
directly. That is the no issue.
okay.
Okay, if you can directly apply, so basically this voltage is 2 volt. So we are getting a 2 volt here. Okay, this voltage is 2 volts. Now you apply the KCL. You are
Yes, sir.
getting again a 4 volt.
Yes, sir.
Okay, so no issue. I just say that there are the two approaches. Either we apply the superposition or we apply the KCL
Okay,
directly.
okay, sir. Okay, sir.
Okay, so here we are getting a 4 volt. Okay, now 1 volt is connected in the negative terminal. So because of this 1 volt, we are getting output voltage is minus 1 time RF by R1. Okay, and 4 volt is applied here. Now this 4 voltage will be distributed is across 2 and 4. So what is the voltage we are getting here? Apply voltage divider rule. Okay, and what
Yes,
is the
sir.
voltage divider rule?
4
So
into 4
4
by 2
into
plus 4.
4 divided by 6. Okay, because the voltage drop across this resistance. That is a 4 into 4 divided by 2 plus 4, 6. So that is 16 by 6 volt. Now because of this 16 by 6 volt, we are getting output voltage that is positive 16 by 6 into 1 plus RF by R1. Okay, so minus 1 into RF is 6 divided by 2 plus 16 by 6 into 1 plus 3. So minus 3 plus 16 by 6 into 4. So this is the 3, 2. So minus 3 plus 32 by 3. Okay, so that is 23 by 3, 7.67. Okay.
Yes, sir.
Okay, so that we apply with the help of superposition theorem. Okay, that we solve with the help of superposition theorem. If we directly apply the KCL, so we consider 2 volt here. Okay, we know that in the if op-amp is the negative feedback and op-amp is ideal, no current go inside, so I is 0, inside current is 0. If current inside is this 0, so the voltage of across this 2 kilo ohm is 0. So output voltage at this point is 2 volts. If voltage at this point is 2 volt, that means voltage at this point is also 2 volts. Okay, now you consider that the current that is coming here, it will be go in this one and this one. Okay, so if you apply directly, so the equation is 2 minus 2 incoming current divided by 2k is equal to outgoing current. Outgoing current in this branch is 2 divided by 4, and outgoing current in this branch is equal to 2 minus V naught divided by 4. Okay. So this becomes 0 because 2 minus 2. So 0 is equal to k, and k cancel out. So 2 by 4 and 2 by 4 is 1 minus V naught by 4. So directly we are getting V naught 1 is equal to 4 volts. So you can apply in this way also. Okay. So either you apply the K superposition theorem. First, output voltage because of the positive voltage. Second, output voltage because of the negative voltage. Now add these two voltages to get the final output. Or you directly apply the KCL to get the final output at this point. Both will be same. Method will be different, approach will be different, but answer will be same. Clear? Any doubt?
Yes, sir.
Any other question? Yes, any other question? So if no doubt in week 1, week 2, we start the week 3?
Hello.
Yes.
Sir, I would doubt in a what is the difference between feed forward and feedback system?
Feed forward and feedback.
Yeah.
Okay. So I just start with the block diagram. Okay. This is the A. B. V in, V and V out. Okay, so feedback is what? If we take the in output V out, okay, some part of the output to feed again with the input to get a controlled output. That is called the feedback. Okay, here in this particularly in this block diagram, what we do, we take a output, multiply with the some factor beta, and some this particularly add this particularly feedback factor with the input to reduce the error signal, or we are saying the control the output voltage. That is the feedback. Okay, any doubt?
No, sir.
So that, like for example, if you are operating the AC, okay, you are saying that basically I just set a temperature 24 degrees centigrade, and after some time I just feel that I am feeling little bit cold. So what should I do? I just increase the temperature or basically switch off the AC. So you are feedback for that one. Output that is coming, that is the airflow. You are the factor. If you feel cold, so what you do, you just control the input by switching off or increase the temperature to maintain the control environment in your room. That is called the feed forward. Okay. Now, sorry, feedback, that is called the feedback. Now feed forward, if we provide some input directly to the output side, in that way that there is some amplification gain factor is there, but along with that
Uh,
amplification gain we have some other
Sir,
part
can you draw the block diagram separately?
for feed forward.
Yeah.
Okay. So we have a so we have we are saying that we have some amplifier. We have the more path B. Okay. Now A is our forward path. Okay. A is our forward path. This is our forward path. C is our feedback path. Okay. And this B, that is called the feed forward path. Feeding some part of the signal directly, that will be go towards the output. If we feeding our signal from output to input, it is a feedback. If we feeding our signal from input to output, that is a feed forward. Okay. If we feed signal from output to input, that will be the path C. I am just saying the path C. That is the feedback path. Okay. And second, if we feed signal from input to output, that is the path B. That is feed forward path. Okay.
No, sir. Sir, I didn't understand the feed forward.
The path, if you feed some signal with some other path, okay, and that path will be adding in the output side. Okay, that path will be adding in the output side, so
Sir,
that is called the feed forward.
sir, it will be good if you go with one example.
One example in the feed forward. mm, what we take as the example is you basically control system is not covered, na? You have not covered the control system.
I guess not yet.
Correct, correct.
But in the week one, they asked about the feed forward.
Feed forward, that is basically if you are talking about the two port network. I think in the when we go with the internal diagram of Y operation amplifier represented in the form of Y parameters. In that one you are discussing feed forward.
No, no. In the week one, in one of the question, they asked about the feed forward.
Which question? So I will take that one as example.
Basically, in that question, they asked about the feed forward. What is the feed forward and all?
So if I take a just practical example of feed forward, take an example of feed forward is, okay. So I just take a one example is that I think you are aware with the UPS or some inverter at your home. I think so.
Yes, sir.
Okay. So there is basically one instrument or appliances. We can say the electricity or fan. There is one particularly path is that is coming from the main electricity supply. Okay. So if I say that I have a fan, okay, that will be coming from some electricity supply. Okay, the output is feedback of that one is user to control the speed of that fan. Okay, now other way is that if light is not there, okay, the feedback path is going in a correct way, but if light is not there, through the UPS or inverter you just operate your fan. Okay, so there are two mechanisms to operate the fan. One is the electricity and second is the UPS. Understood? So there
Like
are two paths to operate that system. So this particularly two path, one is the main path. If main path fails, so we have a supplementary path UPS, and that path is called the feed forward path. And that is the feedback path. Okay. Yes. Not
Yes, sir.
exactly, not exactly the correct, but relate some application that you are generally aware about that one. Either the fan will be go with the direct electricity, or it will be passed through the UPS. UPS will store that particularly energy, and when light will be not no light will be there, so UPS will be operate your system. Okay, so direct main path is your electricity. Mostly you use you operate your fan with the electricity, but sometimes if it fails, so it through the UPS, so your system will be controlled through the UPS power. Okay, so there are two parts to operate the fan. One is the electricity, and one is the through the UPS. Again, the input of that one is the electricity. Okay, again the input of that one both with the electricity. Fan, we use the direct electricity in the UPS or in the inverter. We just store that particular electricity in the battery, and when the light will be gone, so through this battery it will be power will be given to fan through the UPS or inverter. Okay, so there are two parts to operate the fan. One is the direct electricity and one is the UPS. Okay, so that particularly one path is the main path, and second path is the feed forward path.
Then when we talk about the feed forward, there were
Mhm.
no role of the user block, right?
No, exactly. I'm just say that this is the rough diagram. In the UPS, you also can control the speed of that particularly fan. Okay, so there is also the role of that particularly. Okay, maybe we can connect UPS here also. That is as per the requirement.
Okay.
Okay, I am not creating. I just say that I am just giving some example, but I am not creating the correct diagram. Maybe there are some more mechanism also there. Okay, but again the user role is there because in the UPS, when the fan will be operated through the inverter, you can change the speed also at that time. Through the electricity you can also change the speed. Through the UPS you also change the speed.
Means the user block may exist
It may
or
exist.
may not.
Yeah, that is dependent on the application point. Okay, now clear.
Yes, sir.
If we go with the turbines, so there are the multiple feed forward path, because in the turbines generally some system are critical system. So what we do, we are required every time will be that will be operated. Okay, so if we go with the electricity system generations, basically plant, so where the turbines are available, so we generally use the feed forward path in that case.
In this course, we discuss only with negative feedback, or we also deal with the feedback.
No, we consider mostly the negative feedback. Okay, positive feedback will be considered in week 4 if we go with the week 4 content. So in that one we use the positive feedback, but that positive feedback is used for the threshold leveling is as a ischemic trigger, not for the oscillators. General application of the positive feedback is the oscillators, but we are not discussing oscillators here because that system is mostly in the unstable system. Okay, we saw that the gain V out by V in for the positive feedback is A upon 1 minus A beta. So suppose A beta is equal to 1, that particularly V naught upon Vi is infinity. Okay, or we can say the system is unstable. Okay, and unstable system practically we are not discussing here, because if any system is unstable, that is no use, practical use. For the theoretical concept, that is okay. Okay, but for the practical application point of view, there is no particularly system lies that is the unstable. Okay, so we are not discussing for the positive feedback too much. In week 4 we discussed little bit about the positive feedback.
Yeah, okay, sir.
Any other doubt? So, shall we start week 3? If no doubt,
Yes,
week 1 too. Yeah,
yes, sir.
okay. So, I think week 3. Week 3 is basically mainly focused on the single supply operation. Okay, single supply operation. So basically, what happening till now is that we are not consider the supply. Okay, we are not consider the supply voltage. But for the operation of this operation amplifier, for the proper operational, we require some supply voltage. So if we are not considering the supply voltage, we assume that this particularly operation amplifier will work in a stable supply operation. Stable, that means plus VCC here or minus VCC here, or we can say the VSS. This is the output voltage, uh, positive or negative terminal. Okay. In the last class, I think we discussed that your output will be always V out will always less than or equal to the VCC and greater than or equal to the minus VCC or VSS. It never go beyond this range. Okay, it never go beyond this. So for this one, I think if you remember, we draw one curve or graph also. This is the V1 minus V2, and this is V0. Okay, so if we increase the V1 minus V2, okay, the output voltage V0 will be increases, but it will be increased up to a limit, and after that it will be constant. If you increase the V1 minus V2, your V out will not increase. So that particularly limit is called the plus VCC. Similarly, for the negative also it will be constant after a certain voltage, and that is called the minus VCC or VSS. Okay, because we know that this particularly if we apply the input voltage V1 minus V2, okay, this is the V1, this is the V2, uh, the output voltage is A times V1 minus V2. Okay, if we provide the, because you know that open loop gain of the operation amplifier is 10 raised to power 6. So if you apply the millivolts in the input side V1 minus V2, you are getting output voltage is 10 raised to power 6 into millivolt. Okay, so that is the 10 raised to power 3 volts around. Okay, 10 raised to power 3 volts or 1 kilovolt. But that is not possible. If you apply the millivolt, you are getting the output voltage is kilovolt. Why? Because energy conservation. What it says that your output voltage energy will be conserved. If you provide some voltage, if you provide some energy to the input, you not go beyond the a particular range of that energy. Why? Because the output voltage is will be plus 10 or minus 10 voltage or plus 20 or minus 20 voltage. Okay, so we don't go beyond that voltage. Okay, we don't go beyond that voltage. Now the problem is that if the dual supply is there, problem is that you require two different voltage. One is the plus VCC, second is the minus VCC. Now how you convert the plus VCC and minus VCC, or plus 10 or minus 10? You have a supply voltage of 220 volts. Okay, now this 220 volts you have to convert into the 10 volt or 10 volt, you have to reduce the voltage. So basically, first of all, we require the step down. Okay, you require the step down. Step down. With the step down, you will get the 12 volt. Now this 12 volt is the AC signal. You have a AC signal. You have a AC signal. Now you require the AC to DC converter. So you require a 12 volt, that is the pulsating DC rectifier. Okay, and after that 12 volt pulsating DC, you require a 10 volts constant DC. That you use the regulator. Okay, so you process with the three different blocks and you get the 10 volt. Now again you required a minus 10 volt also. So till AC, okay, fine. After that you required a rectifier that will be converted minus 12 volt. Now that is the pulsating. Now you required a minus 10 volt by regulator. So you required a two different circuits to generate a plus 10 volt and minus 10 volt. Okay, so that part is little bit complicated. So to avoid this situation, what we use a single supply operator. Okay, we use a single supply operator. The benefit of single supply operator is you require only one supply voltage. Okay, you required only one supply voltage. If you required a one supply voltage, okay, so I'm just taking one example, plus minus. This is the ground, 2 kilo ohm. 2 volts. So yeah, 6 volts, 6 kilo ohm, 1 kilo ohm or 2 kilo ohm, and the output voltage we know. Okay, you provide a supply of plus 10 volt and minus 10 volt. So what is the output? What is the output? Yes, what is the output? Anyone? We are working on a dual supply. Okay, we provide the input voltage 2 volt on a negative terminal. The Rin is 2 kilo ohm and RF is 6 kilo ohm. So what is the output voltage? V naught is direct minus RF by R1 yeah, Rf by Rn into V minus. Okay, so that is minus 6 by 2 into 2 volts. So that means minus 6 volt. Okay. Yes, any doubt? Yes, any doubt? Am I audible to all?
Yes, sir. No doubt.
Okay. Uh, okay. So we are getting the output voltage is V out is minus 6 volt. Now, if we convert this minus 6 volt will be the output voltage minus 6 volt will be in between the 10 volts and minus 10 volts. Okay, that means it minus 6 output voltage will be lies within the range of supply signal, that is minus 10 and plus 10. So if we have a range from plus 10 minus 10 to plus 10, the output voltage is minus 6 volt. That means this is 4 level 4 volt above the lowest possible output voltage. Okay, what is the lowest output possible voltage is minus 10, and what is the highest output possible voltage is plus 10. So it is 4 volt above the lowest possible output voltage. Clear? Now what we do is that we convert this particularly into the single supply operation. Single supply operation means we add a plus 10 volt here and we add a plus 10 volt here. So now my circuit will be 2 kilo ohm plus, it is grounded, 2 kilo ohm, 2 volts minus 6 kilo ohm. Now my supply voltage will be the 20 volts and ground. Now what we do, we have to shift my output voltage also. Why? Because now output voltage is minus 6 volt, that will not in the range, because we change our range from 0 to 20 volts. So what is the minimum, what is the lowest range is 0 volt, what is the highest range is 20 volts. My output voltage will be lies between 0 to 20 volts. Okay, so if I increase my supply voltage up to the 10 volts, I have to increase my output voltage also by 10 volts. So minus 6 is the previous output, I add a plus 10 volt. That means I am getting V out is the 4 volt. I am getting now V out is the 4 volt. Now in the previous case, the output voltage is 4 volt higher than the lowest voltage, and the lowest voltage is minus 10 volt. Now in this case, if we add a 10, then my output voltage is 4 volt, that is also 4 volt higher than the lowest level, because the now the lowest level is 0 volt. Understood? So if I increase 10 volt into the supply voltage, I have to boost or basically increase my output voltage also the same level with the same level. Now how we get this plus 10 volt? How we get this plus 10 volt? So the thing is that if we have to require this 10 volt, if we require this 10 volt in the output, so we add some voltage here. Okay, I just added 10 volt here. Okay, I just add a 10 volt here. So because of 2 volt I know that I am getting the minus 6 volt. Okay, because of this minus 10 volt, what should I get? Minus 10 times RF by R1. Minus 10 times RF by R1. Okay. So my initially we are getting a minus 6 volt. Now we are getting a minus 10. That means negative, more negative voltage. To reduce the effect of this one, I add a 10 volt also here. Okay, 10 volt also here. So because of this 10 volt, we are having a component is 10 times 1 plus RF by R1. If I solve this one, so minus 10 RF by R1 and plus 10 RF by R1 both are cancelled out. So the remaining is 10 volt we are getting. So if we add a 10 volt in the negative positive terminal and a 10 volt in the negative terminal, we are getting this 10 volt. And that 10 volt is we are already added in the output. To convert my output previous output voltage into that will be lie in the range new range 0 to 20 volts. Okay, so in the single supply
Sir,
operation,
sir, after adding 10 volt here, total voltage will be 10 plus 2 na 12. Then
which one?
when
Yeah,
you add
this one,
10 volt,
12 volt.
yeah.
Okay, so 2
Now
volt because
after,
of this 2 volt, because of this volt we are also getting the 6 minus 6 volt, no?
yes, then you add there
10
two
volts,
10,
10 volts. So because of this
then
10 volt, I am getting one more component. Minus 6 is already there,
yes,
but because of this 10, I am getting this factor.
yes, sir.
Okay, and because of this 10, I am getting this factor. So my output voltage is what? Minus 6 already plus 10 volt. So that will be 4 volt.
Yeah,
Okay, we require the 4 volt.
yes, sir.
Understood?
Yes, sir.
Okay. So now if we operate my operation amplifier in a single supply, we have to boost my signal. Initially, I just say that this is the VCC by 2 and this is the minus VCC by 2. This will be grounded, connected with the input, sorry, RA. This is the VI. V out. Okay. To convert into the single supply voltage, what should I do? I just this voltage will be the grounded. So I add a VCC by 2 here, VCC by 2 here. Okay. If I add a VCC by 2 and VCC by 2 here, so I have to add this VCC by 2 at every terminal. So I add a VCC by 2 here. I add a VCC by 2 here, or I had a VCC by 2 here. The similar approach that we discuss here. Okay, initially 2 volt are there. Because of 2 volt, we are getting a minus 6 volt. Okay, that will be valid when we use a supply voltage from minus 10 to plus 10. Okay, because of this 2 volts, we are getting output voltage is minus 6 volt. That will be in the range of plus 10 to minus 10. Okay, but when I increase my supply voltage by adding 10 volts, so this is a 20 and ground, 20 and 0 volt. Now this minus 6 will not be in between the range. Output is minus 6. Now this will be not in the range. So what should I do? I have to increase my output voltage level. How much? By adding 10. Why we add 10? Because initially minus 10 is the lowest level and we are getting a minus 6. That is a 4 level above the lowest level. Now my level will be changed. It will be now 0. It will be now 20. Okay. So again, it is 4 voltage level above the lowest level. So if lowest level is 0, so 4 voltage, that means that will be now 4 volt. How we get from minus 6 to 4? Plus a 10 volt also here. So in the output, we are getting a 10 volt. So I am adding a VCC by 2. Okay. Now, how we get this VCC by 2? If we add the same voltage in the negative terminal and same voltage in the positive terminal, because the negative and positive terminal RF by R1 factor will be cancelled out. Okay. This factor and this factor will be cancelled out. Okay. The remaining is only this factor is remain minus 10. So this minus 10 we are getting in the output. Okay, we required only 10 volts. So how we get this one? The same voltage we apply on the positive and negative terminal. So we are getting the same voltage at the output. Clear? So that's why in the DC, basically when we operate into a single supply voltage, we add a constant voltage with every terminal. Either it is an inverting terminal, either it is a non-inverting terminal, either it is a positive supply, either it is a negative supply, either it is a V out. So all 5 terminal we add the same voltage, that is the VCC by 2. Clear?
Yes, sir.
Now, if we get the output voltage VCC by, in place of VCC by 2, if I get the voltage at VCC, so we apply a battery, that is the VCC by 2 with the opposite polarity. So I am getting V out here. I am getting V out here. Any doubt? Okay, I think no doubt.
The main concept is we have to ground.
Yeah, we have to convert 2 supplies. Okay, we have initially 2 supply voltage we required. One is the plus VCC and second is the minus VCC or VSS.
Yes, we have to ground minus VCC.
Minus
This
VCC.
is our main target.
Yeah,
What is the
to
value
convert in
of
a single
the
supply.
VCC? Yes.
That is
What is the
dependent on the operation amplifier. Maybe
yeah.
the operation amplifier will be operate on the 5 volt. Generally, it will be the 9 volt, 12 volt, 15 volt, or 20 volts. Okay, which application we are using? According to this one, we decide which operation amplifier we have to use. In the market, it is available either 5, 9, 12, 15, and 20 volts. Okay.
Yes, sir. Okay.
I think in analog electronics you are using the MCP 6004. That is the operation amplifier. I think that will be operated in 9 volt. No, that will be operated with the 5 volt. Okay. You have a 741. I think operation amplifier 741 that will be operated is the 9 volt. So according to the applications we required, that is all dependent on which type of load we have. If we required a load that is a high power load, so we required a higher voltage. Okay, so we are using the operation amplifier that required the high VCC plus minus VCC. So according to application, according to the load behavior, we can choose our operation amplifier. Okay.
Yes, sir.
But because of this one main reason of that one, why we go with the single supply to convert a 220 volt, because when we create a system, okay, we can't rely on a battery. We have to connect a system that will be operated on a AC supply also. Okay, any system, if we are taking if you create any product like your mobile phone or your you can say your smart watches, your Bluetooth, so you can use a battery for a limited time. Okay, but if you reliable on a system, if you create a reliable system, then you required AC supply also. Okay, if you use a mobile phone, your battery is 100%. Okay, fine. If it is 0, you connect with the AC. So that means anyhow you required a 220 volt supply. Now 220 volt to 5 volt or 9 volt, which operation amplifier you are using, convert a plus 5 volt and minus 5 volt, that particularly a two different circuit you required for that. Okay, so your complexity is increases, as well as you have a three different voltage level, plus 5, ground and minus 5. So that is a if circuit is small, okay, fine. But if you required a more component and you operate with the three supply, there is a little bit confusion in that. Which terminal we want to connect, plus 5, which terminal we want to connect a minus 5, which terminal we want to connect a ground voltage. So to avoid this complexity, what should we do? We convert a three supply voltage into a two supply voltage. One is the plus 5 and 0, plus 10 or 0, plus 15 or 0, anything. Okay, so you have a two particular labels. One is the positive and second is the ground 0. Is it fine?
Yes, sir. Yes, sir. Fine.
So that's why for the practical application, we generally work on the single supply operation amplifier. Now, again, the problem is same. What is the problem here? Is we again required two different batteries. Okay, we again required two different batteries. One battery with the VCC supply, one battery with the VCC supply, and one with the VCC by 2 supply. So if VCC are 10 volts, so you require two batteries. One is the 10 volt battery and one is the 5 volt battery. Again, the problem is same. Okay, so now level is 10 volt, 5 volt, and ground 0 volt. So again, three levels. So what should I do? To generate this VCC by 2, we required a voltage divider, the Rx and Rx. Okay, now this VCC is constant. You can connect with the same VCC. Okay, here we are getting a VCC by 2. So this point you will be your VCC by 2, because this VCC will be divided in Rx and Rx. If both resistors are equal, so that means distribution is equal. So VCC by 2 you are getting here, and VCC by 2 you are getting here. Okay. So this 5 volt you are getting from this 10 volt using the voltage divider. Okay. Any doubt? Yes, any doubt?
No, sir.
Okay. Now the thing is that you convert the VCC into VCC by 2, but we use this VCC by 2 here and here. That means the VCC by 2 that you convert from the VCC, you have to store this VCC by 2 somewhere. What is the option of that storage? Either you provide a battery, VCC by 2. Okay, if I connect a V in here, that is a positive terminal, negative terminal. Again, battery, VCC by 2. There is one resistor, one resistor. Again, you require one battery. Okay, so you required a battery with the VCC by 2 voltage. Okay, this is the first option. But the problem with the battery is that you connect VCC by 2 plus VCC by 2, you connect a ground. That means minus VCC by 2 plus VCC by 2. Okay, so the problem is that you convert this one 220 volt to directly 10 volt and apply here. That will be connected with the ground. Okay, so that 10 volt voltage level is always a constant voltage level you provide here. But the battery, okay, if battery will be discharged, and you are getting a less voltage, VCC by 2 minus del V here, okay, VCC by 2 minus del V2 here. I just say that it is a V1, it is a V2, and del VCC minus del V3. Okay, you are getting sometimes, after some time your battery will be discharged, and the discharge level of all three battery will be different. So here the voltage is del V1, it is reduced than VCC by 2, Here it is a del V3, that means it is a, this voltage will be different with this one, and this voltage, all two voltage will be different with output voltage. So you are not getting a correct output. Okay, one battery may be new, so it will be discharged slowly. One battery will be old, that will be discharged fastly. So may be possible that discharging voltage of different batteries will be different. Okay, and if the discharging level is different, so you are getting a different voltage. So your output is will never be a correct output. Okay, so the other way is that we use a capacitor. We use a capacitor and provide a voltage divider biasing here. Provide a voltage divider biasing. So this voltage divider biasing will be this VCC by 2. This VCC by 2 is applied across this capacitor. That means this capacitor will always charge by the VCC by 2 supply. Okay, so this particularly capacitor will be providing you the constant VCC by 2 supply in one condition when the capacitance is infinity. What is the meaning of capacitance infinity? Because you know that capacitor discharging will be dependent on the time constant, that is the RC. Okay, and charging and discharging equation is will be minus T by RC. Okay, e raised to power minus T by RC. So if C is infinite, so that means RC is infinite. And if RC is infinite, so e raised to power T upon infinite, that means e raised to power 0. Okay, and if it is multiply with VCC by 2, VCC by 2, so you are always getting a VCC by 2 supply. Okay, you are always. Okay, so you are getting a VCC by 2 constant voltage if your C will be infinite. Okay, similarly, you can apply the same capacitance C is equal to infinite here. Okay, and these two capacitance will be called the coupling capacitor. One is this one and one is this one. This is called the coupling capacitor. Why coupling capacitor? Because this capacitor will be couple input signal in the input of the operation amplifier, and this particularly capacitor will be couple your output signal of the operation amplifier with another stage. Okay, because that output will be connect, you can connect with the other circuit to control that particular output. So basically the output of first operation amplifier will be coupled into the another stage, another maybe the transistor or maybe the another one more operation amplifier is there. So in between them we use the capacitor, so it is called the coupling capacitors.
Sir, to reduce del V, voltage deviation, we use capacitor.
Yeah, we in place of battery, because battery charging and discharging we can't consider define. Okay, but capacitor charging and discharging we can define.
Yes, sir.
So that's why the variation in 3 voltage will be possible if we use the battery. So in place of battery, what should we do? We use the capacitors.
Okay.
Okay, like for example, you have a 3 different companies cell. You already have that particularly AA cell. Okay, you can take one is the Duracell, one is the Eveready, and one is the Nipo. you can't say that after using the 1 hour the voltage will be same for all three batteries.
Okay.
The voltage, initial voltage will be same, the basically current rating will be same, but after using the 1 hour we can't say the all three batteries have a same voltage remaining. So that's why we can't control that particularly behavior. So what should we do? We know that in place of capacitor, in place of battery, if we use the capacitor, capacitor can also be used as a battery. Okay, because it can store the charge. How much charge it can store, what time, how much time it will be take to charge and discharge, that is all dependent on the time constant. Okay, to increase the time constant, what should we do? We increase the capacitance, that will be the infinite. Okay, so ideally we use the capacitor with the infinite value. Okay, any other doubt?
Yes.
Yes, any other doubt?
Sir, then in negative terminal, from where we give VCC by 2?
We are using the same particularly capacitor, we use that same capacitor to provide the VCC by 2 at the here.
Okay.
Yeah, someone messaged that in the grade assignment week 2 question to answer is 449, but compared to question 1 0, so this can I write 500 as the answer of Q2. So question number 1. The question number 1 we are giving the range because there are the 3 decimal points. Okay, but question 2 the answer is direct, so we are using only the single value 499. 500 is the wrong. Someone asked I think Nityayan.
Yes, sir. Yes, sir.
The question 2 400 499 is the correct answer. We are not giving the range for that.
Okay, sir.
Till now, any doubt? Why we use single supply? To reduce the complexity. Okay, to basically convert a complete circuit into the two supply. One is the plus VCC and second is the ground. We are not considering the 3 voltage level. That's why we convert into the single supply. How we convert into the single supply? If we provide the single supply voltage, so we have to boost our voltage level at every points, every nodes. What are the nodes? Either the positive supply, either the negative supply, output, positive inverting terminal and non-inverting terminal. So we have to boost all voltage with the same voltage. That is the VCC by 2. Okay. So there is no change when we boost all the voltage level at a same level. Correct? Any doubt? Now, how we provide the VCC? Again, the problem is that we are required the 3 voltage VCC by 2 and ground. So 3 voltage level. So we avoid the problem of VCC by 2 by using the same VCC and use a voltage divider biasing circuit. Okay, so voltage divider biasing, we use the 2 equal resistance. So that particularly voltage divider biasing circuit will divide this voltage VCC by 2 we generate from there. Okay, we use this VCC by 2 But the problem is that either we use the battery or we use the capacitor. So battery, if we use three different batteries, so we can't control the charging and discharging the voltage level of that particularly. Okay, because we don't know what material we are using to design a battery. So the best way is that we use the capacitor. Okay. Hmm. Now, how we basically convert a capacitor into battery? We use a high capacitance value. We use a high capacitance value. Okay, if we use a high capacitance value, C is infinite. Ideally, C is infinite, but practically it is not possible. But if C is infinite, so we use this capacitor in the input side, okay, and as well as the output side. These two capacitors is called the coupling capacitors. Okay, any doubt? We move forward.
Yes, sir.
So now if we have, my circuit should be like the so now the thing is that ideally we consider the C should be infinite, but practically the capacitance with infinite value is not possible. So what is the C? We can say that C1 and C2. Okay, what is the value of C1 and C2 should be considered? Yeah. Okay, so across the capacitor we required a voltage drop, that is VCC by 2. So C1, if I say, so C1 the voltage drop is VCC by 2, and similarly the C2 the voltage drop is VCC by 2. So we have the input voltage Vi, along with Vi we connect one RS. We have one capacitor infinite, which is discharge this capacitor. We have a VCC, so resistance are used. Now we say at this point we are getting, what is the voltage we are getting here? So one voltage we are getting this because of this one, that is VCC by 2. Okay, but other, because of this V input we are getting some voltage also. So what is that voltage? If we consider this V in voltage, so this is the grounded, this one is also grounded, this point is short. So these two resistance, I say the RX and RF. Okay, so both will be in parallel. Okay, so can I draw that this is the ground, sorry, V in, this is the RS, C and RX by 2. This is the VA, I say VA. So what is the value of VA? VA is V in into Rx by 2 divided by all. So Rx by 2 plus Rs plus 1 by Yes. That is the VA. Okay, we are considering two voltage. One is the because of VCC. Okay, because of VCC, we are getting the VCC by 2. Okay, so that is the DC voltage. But along with that, VI may be the analog voltage or maybe the DC voltage. So because of this VI, we are getting the voltage that is the VA. So what is the voltage? Output voltage. So V naught is VCC by 2 plus VA time Rx upon Rx by 2 plus Rs plus 1 by Cs. Okay, and if we are taking C is infinite, so V naught is equal to VCC by 2 plus VA into Rx upon Rx by 2 upon
Yes, sir.
Rx by 2 plus Rs. Okay, now this that is a V in, not VA. Okay, so now what we require that the input voltage that we apply, okay, V in that we apply here, the maximum voltage we want it will be as a VA. Okay, we require the input voltage that we apply, the maximum voltage we are getting as a VA. So that means this term should be equal to VA, and that is only possible if your Rx by 2 should be greater than Rs. So now your output voltage VCC by 2 plus V in, this is greater than Rs, so we can neglect this term. Rx by 2 and Rx2 by cancel out, so this is V in multiplied by 1. So we are getting this one as a V. Okay, we require only this term as a V. Okay, now we consider this condition. Now Rs is what? Source resistance. If we consider the ideal voltage source, the value of Rs is 0, but practically the value of Rs is very less. That means this condition may be possible. If we choose Rx in kilo or in mega. Clear?
Yes, sir. Clear.
Similarly, if we are talking about the output side, so this is my V out, VCC by 2, and here it is a RL. So at the output side, we have a circuit. This is the V out, capacitor, RL. and that is this is called the VB. Okay, we call them as a VB. Okay, because VB is nothing but V out plus VCC by 2. If you check here, we are getting V out plus VCC by 2. To eliminate this VCC by 2, we connect this particularly battery in the opposite polarity. Then we are getting the V out. Okay, so that's why I am saying this is the V out plus VCC by 2. That is the VB.
Yes, sir.
Okay. If we are using the V out plus VB here, so what is the output voltage? So basically, what is the transfer function of that one? So V naught upon VB is equal to RL upon RL plus 1 upon
Plus,
SC,
yes, sir.
or we can say SCRL upon 1 plus SCRL. Okay, so with the help of this one, we can find out the value of capacitor. Okay, so if you take a mode, you can take a mode also. So V naught upon VB mode, that will be equal to omega C RL upon 1 plus omega square C square RL square root of this one. Okay, and we want that value should be equal to 1. Why? So we are getting same voltage, this one and this one. Okay, so we are getting a same voltage, so we just want that this should be 1. If this should be 1, so we can say omega C RL is equal to root 1 plus omega square C square RL square. Take a square this side, take a square this side. So it is omega square C square RL square, that is equal to 1 plus omega square C square RL square.
Then it is 1.
Wait a minute. Yeah. That is only possible, that condition is only possible if omega square C square RL square is much greater than 1.
Yes, sir.
Okay, if this is greater than 1, so this particularly value is equal to omega square C square RL square. Okay, if this will be greater than 1, the value of C square should be greater than 1 upon omega square RL square, or C should be greater than 1 upon omega RL. So that will be also dependent on the frequency of operation. The value of capacitance is also dependent on the frequency of operation. The value of C will be also dependent on the output magnitude. Okay, like for example, we consider that this is the one. That means the VB point and V naught will be same. But if we say that V naught is 1% of VB, okay, so what should we do? We just take a magnitude of this one and just put it as a 1 by 100, because V naught is 1% of VB. So 1% VB and VB cancel out, 1% is 1 by 100. If we say
Yes.
that V naught is 10% of VB, so we put that value is 1 by 10.
1 by 10. Yes, sir.
Okay, so in this way we can calculate the value of C. This is the one thing. Second, if V naught and VB both are related to each other, like that, we consider that V naught is equal to VB, but frequency of operation is given. Frequency of operation is 10 kilohertz. Then we know the omega, we know the RL, so we can calculate the value of C.
Yes, sir.
Okay, so anything will be given according to this one, we can calculate the value of C. So ideally we consider the capacitance should be the infinite or maximum, but practically it will be dependent on the condition. Okay, practically it will be dependent on the condition. Which condition? Either the relation between the VB and V naught or the frequency of operation. So if we put C is equal to 1 upon omega RL, that will be okay. Okay, if we put a higher value of C is 1 upon omega RL, that will be capacitor will be used as a battery. Okay. Now, thing is that what is the role of the frequency? We know that in the positive half cycle, the capacitor will charge. In the negative half cycle, capacitor will be discharged. Okay. So initially, when
Yes.
the positive half cycle, it will be charged. If our frequency value is higher than this particular range, so before starting the next positive cycle, it will be maintain their voltage level. Again, it will be charged. It will be maintain the voltage level. Again, it will be charged, maintain the voltage level. Okay, if you reduce the value C less than 1 by omega RL, so what happen in that scenario? C will be completely discharged.
Yes, sir.
Then when the voltage will be coming, it will be charged. Again, it will be completely discharged. Then voltage will be coming. Then it will be charged. Again, it will be discharged. Then okay. So the green one will be the when C is less than 1 upon omega RL. Okay. And if the capacitor will be charged and discharged, charged and discharged, charged and discharged, completely discharged, so that we can't use as a VCC by 2. Okay, we can't use that one as a VCC by 2. Okay, this is black one is C greater than or maybe equal to 1 upon omega RL. Okay, and when C will be higher than 1 upon omega RL, so I just draw with the red one. So it will be charge, constant the voltage, minor charge, constant the voltage, minor charge, constant the voltage, minus charge, constant the voltage. Okay, so this red one is C should be greater than 1 upon omega R. Okay, so these are the three different conditions. Okay, so in this way we can decide the value of capacitance.
Okay. Then, sir, output capacitor and input capacitor both are coupling.
Yeah, so both
Then,
will be the different value.
okay.
Okay, that is not a same value. We have a different value of capacitance.
Okay.
The same method you can use for the output voltage. Okay, because if we calculate the capacitance, so what should we do? Equivalent circuit. So this Vi is the grounded, the capacitance time constant you have to calculate. How you can calculate the time constant?
If we know the value of RC, then
how we calculate the time constant? If, like, for example, this circuit is given, R S, this is the grounded, this is the capacitor, this is the RX by RX, and this is the RX. VCC, RX, ground, but here it is PA minus. VA. How we calculate the time constant of this circuit? Yes, anyone? How we calculate the time constant? I think you already covered that one in ESTC and EEC.
Yes, sir. I forgot the formula that uh, 0.6.
Yeah, that is the basically charging and discharging. 0.693 into R1 plus R2 times C, or basically RC. I just show that how you calculate the R and C value in that. There are three C's, three R and one C. Okay, so this C is the okay. Now how we calculate the R?
Total the RS and C are in series.
RS and C are in series. Okay. So basically, what we do
Impedance. We have to
here,
find.
we have to replace all the voltage or current source with their internal resistance.
Yes, sir.
Okay. So generally, we are saying that this is the idle, so the no resistance short. This VCC will be the ground. Okay. Now, with respect to this C, this R. Okay. After this R, it is a grounded. Ground will be connected in these 2 points. Okay, and after that it will be go to C. Okay, so if we pass, current will be flow, current will be direction, this one, from this it will be go there and here, after it will be come here, it will be come here, it will be combined and come there. So this is the path of current flow. Discharge of the capacitor, we can say that the discharging of the capacitor. Okay, so
Okay.
the R is RS is in series with RX and RX. So RS in series with RX, parallel with RX. Okay, these two are parallel. After that, at this point, this current will be added. Okay,
Yes,
so
sir.
this
Yes, sir.
point is short. This second terminal is grounded. So both are in parallel, and that parallel with the RS in series. So RS plus
Yes, sir.
RX parallel with RX. Okay,
Yes,
so this is
yes,
your
sir.
R equivalent.
Yes, sir.
This is your R equivalent.
Yes, sir.
Now, what is the time constant? Time constant is C time R equivalent. RC, time constant, RC circuit, the time constant is RC. So C
Yes, sir.
equivalent time, C into R equivalent. So in this way, you can calculate the internal circuit, input side capacitance value. This is the one way. Either the time constant is given, or you can calculate the frequency. Okay, this is your what is the relation between the voltage at this point, and this input voltage. So V naught is equal to Vi times R in, oh sorry, Rx by 2 upon Rx by 2 plus R S plus 1 by Cs. Okay, so the relation between V out and V in, V out by V in is equal to Rx by 2 upon Rx by 2 plus Rs plus 1 by Cs. So this is the one relation. Okay, either the V out by V in, V out, we are saying this particularly voltage, not a output voltage of operation amplifier. Okay, that is the, you can say that this is the V plus. If we are taking, this is the positive terminal of operation, this is the positive terminal of operation amplifier, so this is the V plus. So better that you can represent as a V plus. Okay, so either V plus upon V in, that is given to you, so in this way you can calculate the capacitance value, or the time constant is given, so in that way you can calculate the capacitance value of input side capacitor. Output side we already calculate, input side either this one is given or this one is given. In this way you can calculate the input side capacitance value.
Okay.
Okay, so the method approach is same, but the value will be different, because in the output side only RL is used to
Yes,
discharge
sir.
this
On
capacitor.
distance. Yeah, yeah.
Okay, but in the input side we have a RS as well as two particularly basically biasing resistor is also used, and that two biasing resistors is in parallel with the input resistance RS. So we have a three resistance combination, series parallel combination. So that resistance will be used to discharge this capacitor. So the discharging resistance will be different, so the value will be different.
Okay.
Understood?
Yes, sir. Understood. Sir, what do you mean by coupling? I can't understand coupling. That is,
Actually, the thing is that generally we use one circuit to feedback other circuit. Okay, here we are only discuss what is the this single supply operation. Okay,
yes, sir.
here we only discuss the single supply operation. Yeah, but the output we are getting after single supply circuit, we use this output for other part.
Okay.
Okay, so basically coupling capacitor is basically used to couple two levels.
Okay.
So first input side, the input voltage that we are getting from some other circuit, we use that particularly input to the this operation amplifier. Either we can use this Vi as a input, that is DC as well as the AC signal. Okay, so
Okay.
the signal will be feed in the operation amplifier. So we couple our input signal into the operation amplifier. So we required one coupling capacitor.
Okay.
Okay, similarly at the output we connect other stage also operation amplifier to increase the gain or something other applications, like in here we are using, yeah, in this question we have two operation amplifier.
Yes, sir.
Output of one operation amplifier will connect to the other input. In between them, if we use the capacitor, so that capacitor is used for coupling part. One
Okay.
output will be coupled with the other input.
Okay.
So that's why it is called the coupling capacitor. Generally, we use capacitor for two purposes. One is the coupling, one is the bypass.
Yes, sir.
Okay, I think in the transistor you also discussed this one.
Yes, sir. Yes, sir.
Okay, any other doubt?
No, sir.
Okay.
Up to it is clear.
So thank you.
Okay, sir. Thank you.